Here we are going to discuss in depth the smart technologies and the systems that are going to be integrated in the buildings. As of going era, the conventional concept of buildings is going away and that is being welcomed by the smart buildings and smart solutions that can make the buildings more efficient and more reliable to use. Instead of using the conventional ways where we were using the heavy materials, we were using the heavy man force, and we were using the conventional systems that were not that much efficient to respond and maintain the levels for the person. So in our today's presentation we are going to explain you in depth the concept of the building smart solutions and the things that we are going to provide you for over here with respect to smart technology systems that will be integrated in the buildings in the near future. So we will be covering all the systems and our today's video might get long because I will try to give you the overview of all the systems and all the services that we can provide you over here. So let's start with our today's presentation. First of all, we're going to discuss the concept of smart building. That what actually is the smart building. So first of all, it is the concept that smart building integrates the technology, automation, and the data analytics. Then it optimizes the performance, the comfort zone level, the safeties, and energy efficiency of the building and the building floors or the building sections which are designed and the design can be the for individual component or individual area of building or for the whole building. This can vary building to building. Then it connects all the MEP systems into the one intelligent ecosystem. So in smart buildings, we can say that all the building systems that are managed and operated by a common endpoint, and usually in that terms we call it as BMS, that is the building management system. From there we can automate all of our services and all the building systems that are integrated together to follow each other and to operate as per requirement of their own. So in smart buildings, all the data is collected and stored in a one unified place. From there, the data analytics are generated time to time, which also study the behavior of the building and the changes in building with respect to time. This change includes the occupancy level of building, the usage of the building, and the behavior of building with respect to multiple terms. So if I try to explain all the things here, the slide presents the importance of the smart building. It will present us that why smart buildings matter. So for that, initiating that, I will talk about the key components that makes our building the smart building. So the first of all, our key component is HVAC system. The second one is the lighting system. The third one is the security of the building. And the fourth one is the connectivity of the building. So HVAC system will what it will do, it is going to control the comfort level of our building with respect to the external climate. Second is our lighting system. It controls the lighting requirement of building with respect to our external lighting conditions of the environment, just like the during day hours, during evenings, during night, during early morning, during sunrise, during sunset. each and everything will be monitored and stored in our BMS, so it can adjust all the things over time to time, including the movement of persons inside the area and outside the area. Then it comes about our security systems. It includes the multiple systems, but here in security I have also added the concept for our fire security as well. So it includes securing your building, securing your people, securing your assets, and securing the overall environment of the building. And the last one is the connectivity that defines how our systems will be connected and how we are going to inform our people regarding the any security breach, how we are going to connect our systems with our people and with our building, that it will provide the maximum comfort level to all the people who are there in the building. So what will be the benefits that we will get from it? Now we will talk about the evolution of smart building. I have precised this to a very much linked slide. So let's start with a very brief discussion for each type of the four types that I have defined over here. First of all, we were dealing with the conventional buildings. What were they that in conventional buildings we called them as an isolated system buildings in common. What was the concept that everything and every system in the building that was isolated from the other system, just like if you are going to cool your building during summer season and we have to warm our building during the winter season. We were installing air conditioners for summers and we were installing the heaters for the winter seasons. After that, when there were a bit little improvement, we shifted to the automated building. What was the thing in automated buildings that we installed the concept of building management systems that was controlling all the major systems. So what it did, it just collaborated and integrated your heating, your cooling, your detections and your comfort levels, and then it was being regulated by using the a combined interface of all the services, so it should maintain all the major systems for our building. The next concept is of smart building. It is being regulated by the concept of AI and Internet of Things that we call IoT. Plus, there was some predictive logic that was involved in this concept. So, smart buildings efficiency was very much improved by the automated building. So, it is the concept that is currently ongoing, and all the buildings are being shifted to the smart buildings. So, we can also achieve the zero carbon footprint for every building as well. So, next is our concept of future buildings. That how our So here we will talk about the core components of a smart building. What are the core components that are included in our smart buildings? So there are four major components that makes our building a smart one. The first one is the building management system. It is called the heart and the brain of the whole smart building because it manages, it regulates and controls all the major systems of our building. Then our second thing is the IoT sensors, that is Internet of Things sensors. These sensors are very much important as they reflect all of our operations and their impact all over the building and report them to BMS just to monitor and adjust the building controls over that. Then is our integrated MEP systems. These are the mechanical, electrical and plumbing systems. Actually, while our building is in operations, mechanical, electrical and plumbing, these are the major systems that play the vital role in operations of any building. If these systems are going to be perfect, your building comfort level will be good, your building will be secure, your building will be clean, your building will be tidy, and your building will be a good place to move and to perform its operations. And at number 4, it comes to the data analytics section. In data analytics, all the data that is being collected by the systems and our sensors are reporting it to BMS. It is being stored and analyzed, and that give us the daily monitoring pattern and our loopholes, that where we can improve and what are the major and prime requirements for our buildings. So The next thing that comes in next are our IoT sensors. These sensors will sense and will monitor the different things depending on their requirements. So first of all is the temperature and the humidity sensors. These will detect the internal temperature and humidity level of our building along with the carbon dioxide. So for the brief example, these are being used by HVAC systems, that is used for heating, ventilation and air conditioning. For the temperature that is reported to BMS, it gives a signal that how much hotness or coldness is required within our building premises. And second one, for the humidity, it reports the humidity level of our building to the BMS so that HVAC system can maintain its humidity level to provide the maximum comfort level to building occupants. For CO2, it comes and aligns with our ventilation system, that how much oxygen is being required so that we can mix the exact amount of the fresh air within our flowing air that is flowing within the building, so that there must be a good space and good room for breathing of all the people. Second one are our motion and occupancy detectors. These sensors, what they do, they play the vital role for our lighting system. It is just because when our lighting is integrated with BMS, it monitors the movement of persons, their motion and their occupancy, and then decides based on the installed data that how much is required, how much light is required at a specified place at the specified time. Then is our pressure and flow. It automatically monitors. Next is our automation platforms section. So here we are going to talk about our automation platforms. There are four major components or parts that we can say in our automation platforms. First is automated rules and triggers. Second is our central dashboard control. Third one is a real-time monitoring, and last one, the fourth is fault, alert, and alarm. So in automated rules and triggers, we will just take an example that we have defined a rule in our system and we have defined the triggering point of our system, that at this point our system is going to be automatically behave in this way, and whenever this event has happened or is being monitored, then it will immediately trigger our system. Just for its example, let's take an example of firefighting system. Either that can be the sprinkler system or the fire detection system. Whenever the fire is detected, fire alarm will goes on automatically. It will warn all the occupants of the building regarding the fire, and then automatically it will turn on our sprinkler system for firefighting, so our fire can be suppressed immediately. Next is our central dashboard control. In central dashboard control, the automation in the building will help us to control our systems from one backend. So one person that will be available and that will be monitoring and managing the system, he can control all the systems of our building from that one system. Just as I have given you the example of the fire, let's continue that. In the Once there is fire and the fire has been suppressed by our sprinkler system, then we need to turn off our firefighting system, the fire sprinkler. And the next one is our AI driven optimization. This is a very important concept that is based on the artificial intelligence, and it is enhancing our buildings efficiency and buildings capacity in a very vast manner. Now let's explore this. So in AI drive optimization, we are dealing with the four major parameters. That includes predictive maintenance, our energy load forecasting, our intelligent scheduling, and fault diagnosis. In predictive maintenance, when we have a data-driven AI system installed, it gives us the parameters for our maintenance requirements and the future maintenance activities in advance. Just as an example, if we have installed some of the IC engines and we are going to change their engine oils after a certain period of times over certain hours of driving that engine. Once our engine has completed that much time in operation or a certain time limit is going to be achieved, it will automatically start giving us a signal that your engine oil needs to be replacement. So for energy load forecasting, it will automatically detect, as we have discussed before, for our lighting system and for our HVAC system. It will automatically detect and senses that at what times, what place, and at what level our energy will be required by the lighting system and by the HVAC system for comfortable indoor environment. Then for intelligent scheduling, just as an example, if you take the case of our automatic lighting system, it will automatically senses and detect the motion and the number of occupants in the area. So next is our BMS, that is our building management system. So as we have talked a little about this before, BMS is called the heart of the smart building. This is because it is integrating our all the major systems. So in our buildings, our major systems are comprises of HVAC system, lighting system, energy system, and the fire detection systems, including the firefighting systems. In BMS, what does its main function is? It is basically the centralized control system which regulates and monitors the performance and the working of our all the systems. So in BMS, let's take a quick example. If there is a fire in a certain area of our building, what will happen? First of all, fire alarm will trigger at that point. It will warn the occupants and the management of the building to take the immediate action to mark themselves as safe. Then it will immediately give response to the backend to BMS that in that specified location we are facing the fire. Once our smoke is rising up and our temperature is getting higher, the sprinklers will burst automatically and it will start throwing water over the area that is fired. For HVAC system, our automatic fire curtains that will automatically start opening, and once fire curtains start opening and covering the specified area, it will immediately break the airflow from that area, so the fire must not spread at any time. For lighting, all of our emergency lighting. Next is a quick review about our BMS core functions. So the first major thing for our BMS core functions is the HVAC systems. So it will maintain the temperature requirement that is required during our operation hours by our building, and it will also regulate the pressure across all the stuff over there, because if our pressure is disturbed over certain areas, it will cause the noise. Our pressure will affect the velocity of our refrigerant and our air that is going to our ducts and through our pipes. So that will cause the noise and will also become the inefficient for our whole system. Next is our lighting automation, that a lighting system will be managed by the occupancy level, by the motion, and by the our building behavior and building response. So it will increase the lifespan and lifetime of our installed lights, and it will also save the energy that will be wasted if there is no one and we're using our commercial lighting. And third one is energy consumption tracking. It will be tracking our energy consumption. Mostly it is done with the hourly analysis initially, that it will be monitoring our energy consumption pattern for every hour, and at the end of day we will give a brief charts and graphs for the whole day, that at which time we are using the maximum energy and at what time we are using the minimum energy in our building. And beside this, if we start going deeply into it, It will also state the following this. Now we will go for a brief overview of our MEP systems. As the name presents, MEP is the abbreviation of mechanical, electrical and plumbing systems that are being used in our buildings. So for mechanical systems, the major systems that we use, that is the HVACR, heating, ventilation, air conditioning and the refrigeration systems. It mainly comprises of HVAC systems, our refrigeration systems, our pumps, our ducts and the respective equipment that is being used to maintain all these. The second one comes to be our electrical system. It contains power, lighting, backup and renewables. Here I must mention that if there is some renewable energy resources or zero carbon energy resources that are installed within the building premises, just like in the form of the solar or in the form of the wind, that comes under the umbrella of electrical systems over there. And the last one for plumbing, we will deal with the water supply, drainage and pumps again. Similarly, in the plumbing, water supply and drainage, there is one more important factor, that is our fire sprinkler system. The piping contains the water for suppression of the fire in the area. So for that connection, all the pipe routing and piping of our firefighting system, that also comes under the umbrella of our plumbing system. And in our plumbing system and in our mechanical system, we are using the. Now we will give smart a small and smart briefing about the mechanical systems that are installed in the smart buildings. So first of all, we have the pumps. We have just as a convention, we just use the conventional pumps, but in smart buildings we are using our smart pumps that are installed with the VFDs. This makes these pumps the smart pump. Here VFD stands for variable frequency drive, and our smart pumps work on the principle that it becomes the system that controls the pump's motor speed by adjusting the frequency and voltage of the electricity it receives, so that how much power we are providing to our pump, it will exactly reflect in the motor speed of our pump. Thus it will be affecting our pump's velocity and pump's pressure. So precisely we can say that our pump curves, that is directly related to the frequency and voltage of the electricity that we are providing to our pump, that will be deciding our pump curve parameters. Next is our pressurization systems. These are mostly in the form of HVAC systems, but there are a lot of more applications. Because we are going to not complicate in this section, so we are just giving you a brief overview. In pressurization system, we can say that our coolant is kept pressurized to perform at its maximum efficiency. Then it comes to our air handling units that comes with the sensors. Just as we have taken an example previously, that in case of fire, the fire curtain will automatically close our AHUs, so the fire must not spread through. So what is our HVAC system? Here we are going to take a brief overview about the smart HVAC system, that what makes our HVAC system the smart one. So first of all, it is our VRF, VAV and advanced HVAC control. So whenever we have variable refrigerant flow and air volumes and our advanced controls, these are being optimized, managed and integrated with our all the systems to make it better. Then second thing that comes along with this, that is our IoT thermostat integration. That our thermostat, that is Internet of Things based. So it will be integrated in our HVAC system just to make it more efficient and make it better one for everyone to get the most out of our HVAC system. Then is the thing for our automated ventilation. Our sensors will automatically detect the requirement for oxygen, so our fresh air intake must be increased with the ongoing air that is being taken from the building and then being refined and going turning back to the building for maintaining its temperature. And last one is our temperature zoning. It defines the requirement of temperature in each of our area, that which area will require more temperature and which area should be supposed to working with the lower temperature. Just as an example, let's take the example of the reception of a hotel or restaurant. Where in the reception area, the movement of people will be more and the area will be more exposed to external air as our door is going to be open and close again. So coming next, we are going to talk about our DCVs, that is demand controlled ventilation in our building. So the first thing for ventilation, it depends on the carbon dioxide volume in our space and on the occupancy level in our building. It reflects that if we have more occupants in a building, then our more oxygen will be required at a point just to maintain the good space for all the people in terms of their breathing. So our CO2 should be removed from the air and fresh oxygen will be added to the air in our building. Then is the factor of energy saving. With the DCVs, we can enhance our energy efficiency of our areas. Then it comes about the ventilation. DCVs ensure the automated ventilation to maintain the air quality of our premises. And the last one step is the same, that is the healthy air quality. This depends on the air that is being coming and how much fresh air we are mixing with our ongoing air that is within the building, because the air quality gets lowered when we are using the same air for a long time. So DCVs make it sure that our fresh air is always going to mix with the ongoing air that is already available in our premises, and we are just using that again and again for the. And the next thing that is the most important, that comes to be the monitoring of our HVAC equipment. In HVAC monitoring, we have our equipments installed, and the main thing that defines the efficiency and the operations of our HVAC equipment, that includes our air handling units, the chillers, and our pumps, because these are the major equipments that we are going to use to regulate our heating, air conditioning and ventilation for our premises. What it does, it works on a very simple and basic principles. It will collect the real-time data from our chillers and from our boilers to analyze their performance and their metrics over there. Then for each of our air handling units, it is going to track that one's performance based on their working and operations. And next, it will define the maintenance requirement for each component of our systems and equipment. It will be, as we discussed before, it will might based on the data that's provided from our manufacturer guides and also with the condition of the equipment, that its efficiency is getting lowered, and this might be the reason. This again comes to data analytics. It will analyze all the data that this time our system was at an efficiency of 80%. Now it's reduced to 60%. And what could be the reason? That can be any one that is defined in our system already over there. And the next one and the last fourth is our filter change notifications. whenever we are going to use. So the next come to be our fire protection systems. In our fire protection systems, these mainly includes our system that we use to suppress our fire. The most commonly and frequently used for fire protection, that is our fire sprinkler system. We used fire sprinklers for suppression of our fire by automatically bursting the sprinkler heads so they may start throwing water at the place where we have the fire, so it can be immediately rectified, and we must prevent the more area for getting damaged by lowering the chances of spreading of our fire. Second one, we have the hose reels and fire hydrants installed all over building. Since our hose reels and hydrants are operated manually, so the first point for our fire prevention is our protections, and in case of fire, the first line warrior, that is our sprinkler system. And the second one comes to be the hose reels and hydrants. This is because these are operated manually, not automatically. And the third one is our fire pump, because once our fire is detected and our system has started suppressing the fire, our pumps will start getting will turn on automatically. This is because they will provide the enough pressure and flow at that area as to maintain our condition for securing our space from the spreading of fire and suppression of the fire that has been ignited. And the last one is the integration with alarms and BMS. This is because once there is a fire, so our next thing that is for fire, that comes to the fire detection and fire alarms. In fire detection, we have multiple type of detectors that we do use. The first one is our smoke detectors. In case of any fire, it detects the smoke that is approaching the smoke detectors, so it might notify all over that there is smoke inside the building. And the next comes to be the heat detectors. When there is a fire in an area, the temperature starts getting higher and our area is going to be getting heated. Once the heat arises, the our heat detector will senses the heat and will give alarm for the heats over there. Then we have the CO detectors, that is the carbon monoxide detectors. If it detects the carbon monoxide quantity is getting increased in our area, it will automatically start giving signals that CO is now at a risk. And then is our flame detectors. If we have the flames at unusual places, then it will immediately detect the flame and will inform our system, and it gives the signal to our alarm panel just to trigger. And for our alarm panels in our smart buildings, we only use the addressable fire panels. This is just because in the control room, it will just give the exact location of our loops and systems over there, that at what point we are going to face the issues that might be there due to smoke, due to heat, due to fire, due to excessive gases or anything. It will just not only give you the level of floor or not the whole building. It will. And then we are going to discuss a brief about our sprinkler system essentials. While we are going to design and install the sprinkler system for our building, we have to configure and confirm several parameters for that. First of all, we are going to decide the system type of sprinkler that we're going to install. Either they can be wet, they can be dry, or they can be pre-action, depending on the requirements and availability of the area. Just as an example, if we have the area of normal temperature or hot temperature, we will be using the wet risers over there. That will be our wet sprinkler system. But if in case we are going to install our sprinklers in an area that is very much cold, we are not allowed to use the wet risers, the wet sprinkler system. This is just because our water inside pipes that will get freeze, and if there is some unusual event of fire that's going to be occur or has occurred, our system is not going to ignite, our system is not going to activate over there so as to prevent the fire, because the water inside the pipeline that is already freezed. So we are going to use dry system over there. Then we do the step of hydraulic calculations, so that our pump that is going to be used with our system, that should be accurate with our requirement, that we have the fire at the most remote area. It must be in that much enough to provide the maximum pressure to our water so it can easily continue for suppressing our fire. And then is our spacing rule for sprinklers, that our sprinkler coverage areas must be good, so it is going to cover all over. And then is our pump sizing, that is defined in hydraulic calculations. And the next one is our fire systems integration. It is the main concept for our fire alarms. It comes with our HVAC shutdown, our elevators grounding, and our BMS notifications and lodging. So whenever our HVAC system is going to shut down, the fire alarm will automatically start giving signals to people that HVAC system has been shut down, and this is just because of the some issue with the fire. Because whenever we have fire in our building, for our smart buildings, it is going to shut off our HVAC system immediately, just to control the spreading of fire. And if there is smoke that is detected over there, it will start giving signals from the smoke detectors that the smoke is going to be increased in this area, so it will be more vulnerable, so people must execute from over there. It will start giving us alarms. And the next we were planning to go this for part 2, but for now we're going to add this up with our part 1 to give it you the better overview for the whole system. For over here we are going to discuss about the fire protection for our ELV systems, that are our electrical low voltage systems, and then we will be talking about our energy management over there. And in our energy we will be talking not about the electrical or mechanical energy, we will also be including our hydraulic over here, and this will be comprising of our water management systems as well. And finally we will be discussing our digital twin integration over here as well. As promised with you all in the start, that I will give you a quick review about the digital twins in buildings as well. So let's continue to our next. So here for our fire protection systems. Now we'll just go for the deep diving for the brief overview that I have given to you. So for fire protection systems, we will have the sprinkler system architecture, we will have fire pumps and control panels, we will have the zonal and control assemblies, and we will have the system monitoring and testing. So just quickly, sprinkler system architecture, it comprises of our sprinkler system layouts, that how we are going to place our sprinklers for the whole area but we're going to protect. Then it comes to be the fire pumps and control panels. It is the main fire pump that we have decided based on our hydraulic calculations, that how it is going to operate and what things it must be comprises of to maintain our specified flow and pressure. Then will be the part of our control assemblies. uh, Whatever we are going to do with our system, we will define the zones for each level or each specific segments, and we will give of the zone control valves over there, that in case of event in that specified zone, only that zone control valve will open and it will start providing all the water flow to the specified area of the zone. Then system monitoring and testing. For system monitoring and testing, we always install a test line with our zone control assemblies. So we can test our system though that it might be able to process at the time of any event. Forward, we are going to have a quick look for our types of sprinkler systems that we are going to install over there. So here we have the five prime types that includes the wet sprinkler system, the dry sprinkler system, the pre-action sprinkler system, the dilute sprinkler system, and our gas or mist sprinkler systems. These mainly comes under the umbrella of fire suppression systems. These are basically used for the systems in which we cannot use water to suppress the fire. Just as an example, if we are talking about the kitchen hood systems, we cannot use water over there because it might be igniting our fire, just as there will be too much edibles and cooking oils over there. In wet system, we have water already filled up in our pipes. In dry system, we do not have fed water in our pipes, but it is available in our reservoir. So once there is some event, it will automatically trigger our sprinkler and water will start flowing immediately through its nodes to suppress the fire. Next is our fire pumping systems. In our fire pumping systems, we always give the pump set for our firefighting system, because if there is some unusual event and one of our pump is not working good or due to fire, there are some restrictions in the operations of that pump, we can use the alternate pump. Just as an example, if the fire has caused damage to our electrical systems and our electrical circuits have shut down immediately, then the backup diesel pump that will be managing our system. So in pump set, what we usually use for all over the global market, that is one electrical pump, one diesel pump, and one jockey pump. So electrical and diesel pumps, these are the major fire pumps that are used to supply water in case of any unhappening events. Jockey pump is used to function hour to check the functions of our system just for testing purposes. And then is the flow testing and pressure maintenance. These both are mainly maintained in our system using the jockey pump when our system is going to be normal. But once there is some incident or accident, then our electrical and diesel pumps come into action and start working over there. So now we are going to move for our fire detection and alarm systems. For alarm systems, we have two types. One is addressable and one is conventional. In conventional system, it only our system in conventional, it only presents that there is some unusual happening. Either the fire is detected or smoke is detected over the building. it, it is never going to tell us about the location and premises of that. Just as an example, if our building is comprising of 5 floors, it will only let us know that there is a fire in the building, but it is unable to tell us that in which part of building we are getting the fire and the hazard. So for our addressable system, it will give us the exact location of our fire so that it can be rectified and it can people evacuation can be completed very much fastly and easily over there. Then we have detector system over there. Our majorly two systems are being used. Two alarms are being used, that is smoke detector and heat detector, along with the fire alarm system. Then our comes to be the alarm routing logic. This defines our routing of our fire alarms, that what should be the routing and what should be the plan of our fire alarms. Then again it comes to be the integration, that is going to be with the emergency controls and our BMS. In emergency controls, we can also integrate directly our alarm system with the local municipal council, a fire brigade system as well, and emergency response teams of the national level as well. So once there is some unusual event, it is automatically notified to government officials as well. Now we'll talk a little about the integration of fire systems with our BMS. First of all, the benefit of integration of fire with BMS is the automatic HVAC shutdown. Once there is an event of fire, our HVAC system will be switched off automatically by our BMS. This is done mainly because to prevent the spreading of a fire via ducts, because we have the air that is continuously flowing through our ducts and AHUs. Then is the elevator recall, that our elevators must be recalled and remonitored by BMS, that if there are some issues with the fire system and with the shutdowns, so elevators must be immediately turned off for the maximum protection of the occupants, that whenever there is a rush in our area and people are running very fastly, elevator must not be an obstruction for them to evacuate. And then is our smoke control activation. It is done just to lower the amount of smoke in our area, just to maintain it easy for people to breathe over that area. Then the real time alarms, so that it will be giving the real alarms to our BMS just to operate at its good. And then we will move to our electrical system in smart buildings. So in smart buildings, the most important component of our electrical system that are our main distribution boards, because from their main distribution boards we control the total overall distribution and power supplies of our whole building over there. Then it comes to be the smart metering of our building. It directly resonates with the monitoring of our energy consumption for each sections and segments within our building. Then we have our power backup options, that whenever we are going to get some unusual thing and our main power supply line is break up due to energy or due to some any of the reason, so that our building is not going to shut down in any case. These for small power requirements we use the UPS, uninterrupted power supplies with our installed batteries that are stored with the energy, or our generators. Then final one is our load balancing and monitoring. Our BMS will monitor and balance the electrical load so it can be distributed wholly and uniformly all over. So then in electrical system we comes to our smart lighting systems. As I have talked to you before, we will just get a quick review over here as well. Our smart lighting, it gets the detection of the motion in the area, that our sensors will tell us if there is some occupancy level in that area. Just as an example, for the washrooms and restrooms, if someone will go in, our light will be turned on automatically, and once there is no occupant over there, it will be turned off automatically. And besides this, we also have to install the daylight sensors over there as well. And it will automatically detect that if if we have the light that is coming from our atmosphere, then it means we do not need any additional or artificial lighting. Then is our dimming automation, that whenever we have the some better light from outside or our workload is not that much, we need a lot of lighting over there, it will automatically dim our lights to save energies. Then we have the LED controls via BMS. Then we have the energy saving strategies. It will give us the data sheet for our energy consumption pattern, so we can save our energy over there by implementing and refining lighting systems over there. Then in electrical systems there comes to be the renewable energy integration. The major sources for that are our solar, photovoltaic cells and our wind power. So for solar photovoltaics, these are installed on the rooftop of our building so as to capture the maximum solar light and the daylight from all over. Then we have the inverter and energy storage. What our inverter does, they convert the acquired energy into the our current, so we can store that energy in our batteries. But now we are going to use the cells as well. The difference is that our battery takes a lot of space for storage, while cells can store much more energy as compared to batteries, but at the same time they are also occupying a very little space. Then the thing is grid interconnection. Just in case we are using the solar, we will be using the energy that is going to be consumed by our building. We will then start storing energy, and once our storage capacity is completed, it will start giving energy back to the grid. Then again it comes to the monitoring via BMS or EMS. Now we will talk about the ELV systems overview. These are extra low voltage systems. It means that our ELV systems takes very low voltage to operate for them. But these are equally very much important systems of our building. These are comprises of our CCTV cameras, our access control systems, our public area and voice evacuation systems, and then our networking cables. These all comes under the umbrella of our security system, but they are equally important. The most important thing for these is that, as their name told, for extra low voltage, that these systems do not require the high voltage and high electricity consumption in their operations. They operate at a very low electricity and voltage requirement. Then it comes to our CCTV and video analytics. For smart buildings, we use our IP based cameras. Then we used the cameras that are equipped with the motion analytics, that they will study the motion of people and the behavior of everyone who is being captured in our camera. Then it comes with our smart recording. Smart recording means that, just as a quick example, if there is someone who is passing continuously by our camera, it will automatically tell us that this face is being washed this much times of the day or this much times in a specified time. Also, if we would like to detect someone, we can add up their picture in the system and it will give us the person that either that might be over there or not. Then again, in integrated monitoring, we connect it with our BMS system. Now, just regarding our access control systems. This is for getting access to our building. That how one can access and what will the procedure for getting access to our building in any case. These might be the RFIDs or biometrics or the QR access. That whichever person has the stuff, only he can enter the building for the specified defined time. Else they will need someone to assist them or they might need to ask permission for entering the building. Then it comes to the door controllers. Just as you have seen, we have automatically opening and closing doors installed at the big shopping malls and the hotels just to access that building. Then it comes to the integration with the security systems. Just because these systems, all access controls also work to secure our building. So it is also the one of the most important factor for our security systems. Then it also monitors the real-time occupancy level, that how much people have entered the building using the biometrics, how much have the RFIDs, and how much have been entered using the QR access. It also gives us the complete report that for how much period of the day our door is being opened and closed and what is the most busy time for our door opening and closing. Next is our public address and voice evacuation. It includes emergency announcements, integrated evacuation messages, fire panel communication, and system routing. Then there is a system for plumbing. For plumbing in our smart buildings, what we do is we use our smart plumbing systems. We have installed our automatic water quality monitoring modules over there. We do have smart meters to monitor our water consumption pattern for each of sections, and we then define our efficient drainage design so that we must face the minimal restriction in our drainage processes over there. Then we have the smart water management system. It includes the leak detection sensors that whenever we have some leakage at some point, we have detected that there is some leakage is going to happen in this area. We will install our sensors over there. They will sense the motion. You can say in simple words, or technically we can say that they will sense the pressure and velocity of our system. That where it is going to be the abnormal. Then we have the pressure and flow monitoring installed our system. After that, we do have the shut-off valves that are automated to regulate our flow. And then again, water consumption analytics. We record an analytics at our various segments. Just as an example, if we talk about the office, then the most important two things where water is going to be used, that are our washrooms and our kitchens. It will study the pattern of consumption at both areas and will give us the outcome at what point we're using more water. Then, as discussed before, we're going to talk a little about our digital twin concept. What does it do? It present us the real-time data mapping. It give us the concept for predictive maintenance, for performance simulation, and for virtual model of our building systems. That how our buildings can be enhanced in terms of efficiency and their. Now we will talk about the benefit of digital twins. The first and most important benefit is the energy savings. Second one is it identify the faults very fast, and then we can plan our better life cycles for our buildings, and our asset management is improved, and we can secure and we can save a lot of over there. Then for integration in smart buildings for all systems, there are some protocols that we use. The most common protocol is BACnet, the second one is Modbus, the third one is KNX, and last is MQTT, that is based on the IoT communication. And then it comes to our security of our building, and we call it cyber security in a wider range. What does it do? It protects our IoT devices, it protects our network by breaking it into segments and securing each and every segmentation. And then it monitors the digital threats that can happen to our building systems, or if someone can try to hack our building storage devices to gather some data over there. Then the last thing that comes over here, that is the access control and encryption in our. And finally, we are going to talk about future trend in smart buildings. In future trends, it is expected our building operations will start getting autonomous, so that without human interference, they can automatically set them up according to the requirement. Then our building learning is going to be the AI driven. Our building will automatically learn from the parameters, and it will set up its efficiency and consumption requirements according to that. Then our smart filters are going to be zero carbon, so that we will be using the natural resources to generate the energy for them, and our waste that is coming out of the building, that should come to zero. And then we are going to use our advanced robotics in procedure over that. So let's conclude our today's discussion. So here the most important thing is that our smart buildings are reliable on the base of their MEP systems. So we can say that our building becomes smart only when we have the smart and very strong MEP system integration. Second is our automation, IoT and analytics drive efficiency for our building. And lastly, the digital twins that are the futures of our building, and our buildings will be based on that to get the maximum out of them. So that's all.